Okay, y'all, let's take a look at number 2 in the 3B MyLab math homework on energy conversions. And this one's tricky, y'all. It's worded differently than the problems we worked in our notes. Question number 1 and question number 3 on this homework assignment are more closely aligned to how the questions were worded in class, and probably more closely aligned to how you'll see it on a test. But there is a lot of learning to be had in working this problem and careful reading. So let's go ahead and take a look. We are being asked to use this table to answer the following question. If you could generate energy by fusing the hydrogen in solution A, how much of the solution would you need to generate the electrical energy used daily by a certain home? Okay, so don't go any further until you figure out what is your given starting amount and what is your goal. The starting amount in this one is subtle. The goal is a little bit more obvious. We can see we're being asked how much of the solution would you need? And by looking at my table, I see we're measuring that solution in liters. So our goal is going to be liters of solution A. But the given starting amount is not so obvious. So let me read it again. If you could generate energy by fusing the hydrogen in solution A, how much of the solution would you need to generate the electrical energy used daily by a certain home? Daily is the key word there. We're given a quantity of time. Daily means 1 day. So our given starting amount is going to be 1 day. So I'm going to go ahead and write that starting amount as a fraction. I'm just putting it over a 1. It wasn't a rate. It's just a quantity of time. 1 day, I make it a fraction by putting it over a 1. So now we're going to come to this table, and we're going to use the table to create conversion factors. So we need to translate the information in the rows on this table into conversion factors. So let's focus in on this first row here. I'm told that the energy released by fusion of hydrogen in 1 liter of solution A is going to cash in for 7.2 times 10 to the 10th joules. That's joules of energy, so I'm going to write the unit there. Okay, so what does that look like as conversion factors? Okay, well, I can either put the 1 liter of solution in the numerator and cash it in for the 7.2 times 10 to the 10th joules of energy in the denominator, or I can flip-flop that. So that one row of information on the table gives us 2 possible conversion factors. Now let's do the same thing for the second row here. The second row tells me the electrical energy used daily in a certain home cashes in for 6 times 10 to the 9th joules. Again, I need to put joules there. So in 1 day, that home needs 6 times 10 to the 9th joules of energy. 1 day of the energy needs for the home cashes in for 6 times 10 to the 9th joules. So what does that look like as energy, as unit conversions? Well, it looks like either of these fractions. I can put the 1 day in the numerator and the energy that it cashes in for in the denominator, or vice versa. Now, in this problem, it's super tempting to try to start with one of these fractions instead of just starting with 1 day. And it's possible to get the problem right by starting with information in the table, but it's very nuanced. It's very easy to make a mistake or get things out of order. So I only use the information in the table as these unit conversions, as these conversion factors. I never use them as starting amounts. Instead, my starting amount is going to be that 1 day. And by having that 1 day set up as a fraction, then it's going to help me align, using unit analysis, it's going to help me align all the other information so I do the correct calculations. So let's take a look. Okay, so my given starting amount was 1 day, so I need to use one of these unit conversions that involves a day. And since days and my starting amount are in the numerator, I need to use the unit conversion that has days in the denominator. So my units of time, my days will cancel out. And right now my unit that I'm left with is joules. And it's in the numerator. And I know I need to get to liters. So I'm going to use one of these conversion factors that compare joules to liters. And since joules is in the numerator, I need to choose the unit conversion factor that has joules in the denominator. Okay, so now my joules in the numerator will cancel out joules in the denominator, and I'm left with liters of solution, and that was my goal. So I know I've set up all of my fractions correctly. My goal units are in the numerator, and now I'll just follow these calculations to get my final answer. And I'm just going to multiply all the numbers on the top to get a new numerator. Well, I have 1 times 6 times 10 to the 9th times 1. So that's just 6 times 10 to the 9th. And then I have my unit of liters of solution. And then in the denominators, I just had 1 times this power of 10. And there's no units left. So my goal units again are just liters, which is what we wanted. So now I'll just have to type this carefully into my calculator. I'm going to just be extra careful, and I'm going to put that first power of 10 in parentheses divided by the second power of 10 that's in the denominator. I'm also going to put that in parentheses. And be careful with your calculator when you're typing those exponents. Sometimes when you use your exponent button in a calculator, it'll generate another set of parentheses. Sometimes it won't. It'll just automatically create a superscript for you. So just really get to know your calculator. And if you need help with that, you can come to office hours or reach out to one of our tutors. But let's see what we get when we type this into our calculator. Okay, we get the decimal 0.0833333333 repeating liters. And that's our answer. And on a test, that would be totally fine to enter, but MyMathLab is asking us to write this answer in scientific notation. So remember, with scientific notation, we need exactly 1 digit in front of the decimal point, and that digit can't be 0. So I need to push my decimal back 2 place values. So I'm going to end up with 8.3 there times 10 to the what? Well, I know I had to push my decimal by 2 place values. And since the original number, 0.0833333, that's less than 1, it's originally a small number, that exponent's going to be a -2. And then don't forget my units right there. So in MyMathLab, I would enter that answer in scientific notation. On a test, you could leave it just in that decimal form. Okay, so I know there was a lot of moving parts in this problem. Watch this video a couple times. You can click similar problem on similar exercise on MyMathLab over and over and just try this with new numbers again and again. And then reach out to us in office hours, or to one of our amazing tutors, either the instructional associates or an embedded tutor or the tutors at the Learning Lab. You have lots of ways to get help, so use them. Your test will be here before you know it.